for their own purposes.
I'm really concerned for medical purposes. Will you be addressing it with?
No, this is gonna this is gonna be a section on indoor water use today. Yeah. So if you want to hear more about outdoor use, you should go to this one. Not letting the grass grow under their feet panel on residential landscape.
Thank you, Peter.
Well, sorry to lose a participant in our session, but I think you might be better served over there. We're going to be talking toilet.
Check, check.
Good morning, everybody. Welcome to the Water Conservation Home of the Future panel. Hopefully you're here for the one you wanted to come see. My name is Julie Ortiz. I'm with the San Francisco Public Utilities Commission. I'm going to be moderating this panel. I just have a few introductory remarks before we get into our presentations. First of all, I wanted to let you know this is our 16th annual Water Conservation Showcase. Yeah. How many of you have been to all the ones before? All right, yay. So we do try to hold this every year around World Water Day, which is Friday, March 22nd. This is also National Fix a Leak Week, which highlights the importance of taking measures to prevent the trillions of gallons of water lost in leaks every year. The co-organizers for this event include PG&E, East Bay MUD, San Francisco Public Utilities Commission, AIA, City of San Jose. So we thank them as well as our sponsors. And we have a number of exhibitors here today too, so please do try to make sure you stop and visit all the exhibitors. Couple of logistics. We are not handing out printed materials. It saves water not to do so. They will be posted on the waterconservationshowcase.com website. It's going to be in April when they're posted, so check back. We'll also be doing a survey through SurveyMonkey, so look for that in your email and do encourage you to fill it out and give us feedback. For those of you who are here for continuing education credits, this panel this morning provides continuing education credits for the USGBC as well as AIA. If you're here for credits, please record the course number noted on the slide. I'll show this slide again at the end of the session. For USGBC, you self-register online. If you are here for AIA credit, you actually need to sign this hard copy clipboard, which I'll leave up here. So come by at the end of the session and make sure you sign it in. If you don't sign it in, you won't, thank you, Peter, you won't get the AIA credit. Also, do encourage you all, if you can, to stay till 5:30. We have door prizes, some really cool prizes. We'll be doing that here in this room, the conference center. So if you filled out your premium passport card and you submit it to the at the front desk, then you could be eligible for getting a door prize. Restrooms, there are restrooms first floor right around the corner, as well as restrooms upstairs. In the case of emergency, head to that exit here. And there's water dispensers right around the corner as well. And very important, lunch is free. You can pick it up between 11:30 and noon. The line for lunch will be on the second floor in the area noted as lunch service. And all of the Energy Center, which is sponsoring the lunch, is committed to waste-free. So all of the materials are compostable. So napkins, paper cups, toothpicks can all be put into the composting bin. So make sure you do that when you're finished with your lunch. Do ask that everybody silence your cell phones. I don't have a nice little video like they show in the movies, but just put it on mute, please. And I also am going to ask that you hold your questions until we hear from our three panelists. Each will be speaking about 15 minutes, and then we will have time, and I'll bring a microphone around. So this session is being recorded, and it is important, if you don't mind, if you have a question, raise your hand. I'll bring you the microphone. Speak into the microphone, so then it will get picked up on the audio. So with that, I want to introduce our first speaker, Peter Mayer, thank you. Peter is principal and founder of Water DM. He's a professional engineer and urban water expert who has dedicated his career to advancing the science of water efficiency and demand management. For nearly 25 years, Peter's work has focused on urban water management, water use patterns, assessing the impact of water rate structures and metering, evaluating water conservation measures and programs, forecasting future demand with and without conservation, preparing water conservation plans, and conducting water supply scenario analysis. Over his career, Peter has worked with hundreds of water utilities and organizations across the U.S. and Canada and has testified as an expert witness at the U.S. Supreme Court. So with that, I'd like to turn it over to Peter.
Thank you very much. Hopefully this mic is working. You can hear me. So it's a great pleasure to be here in San Francisco today. The Showcase Showdown, that's kind of what I think of when I think of the showcase. It's like I come back to the Price is Right somehow. It's too many days, home from school in front of daytime television. So I'm going to talk about residential water use, and this session today is going to be focused on indoor residential water use. So if you want to hear about outdoor water use, you need to go to the other session, which is focusing outdoors, because we're going to be talking about indoor residential water use. So when we think about indoor residential water use, we're actually thinking about a lot of different types of buildings, everything from high-rise look at how we've done over the last 60 years. This is from the USGS, which is our best national source of water use information. The blue lines are the public withdrawals. That's the total withdrawals for public supply. Public supply is all the water that's withdrawn for cities and towns. And then the green line is the GPCD, and that's just the total withdrawals divided by the total population. So the key thing to see is that the total withdrawals peaked in 2005 and have gone down each of the past 2 years. That's less water withdrawals. That's total water use. On a per person basis, looks like it peaked about 1990, and really we've been on a declining trend ever since 1990. That is largely a result of the Energy Policy Act, plumbing codes, Water Sense program, things that have reduced per capita water use nationwide, and it's really having a significant impact. I suspect when the 2020 data comes out, we'll see continued declines. Perhaps not as dramatic, but at some point we're going to level out, but there is, as I was going to show you, there is additional efficiency to be had. So these savings are happening on all over the country. Here's Metropolitan's GPCD from 1985 to 2015, 36% reduction over 30 years, going from 205 down to 131. But they're not the only one. Here's New York City. This is a little bit of a complicated chart, but just look at the blue line. That's the population. And so if you see from 1980 on, the population of New York has increased. The dark blue line is the overall water demand, and that has gone down. And so you see basically complete split, a divorcing almost of the relationship between population increase and water use. Two of the key things that impacted this in New York: the intervention of universal metering in the early 1990s, and then the program to install 1 million toilets in New York City in the early 1990s, and then the continuation of the savings through WaterSense and through other programs. So this is just to show you that yeah, we are having an impact on water use across the country. So let's look at how these savings are being accomplished. So the Water Research Foundation has sponsored 2 major residential end uses of water studies. I worked on both of them. The first one was published in 1999, and the second one was published in 2016. They're freely available from the Water Research Foundation and a bunch of other places. You probably have seen some of these numbers before. In 1999, the average indoor residential, this is single family, but it's similar to multifamily. The average single family water use indoors was 69.3 gallons per person per day. By 2016, that had reduced to 58.6 gallons per person per day on average. But we know from studies that have simply removed toilets, clothes washers, and showers and faucets and replaced them with WaterSense rated products that these same homes that use 58 or 63 can get down to 36.7 without changing behavior, just through technological change. So if we want to look at what we've accomplished, we saved about 15% over 16, 17 years from 99 to 2016, going from 69 to 58. If we were to get down to 36 or 40 gallons per person per day, we have another 37% reduction. So even a larger percent reduction potentially still exists to achieve indoors. So don't think that we are all the way there yet. There's utilities are going to be in different levels. Some places are going to be much farther along in getting to lower per capita use than others. But the overall message that I want you to know is that the job is not done, and there's a lot more savings that can be had. If we look at where we've accomplished the savings, the 3 categories where there are statistically significant reductions were clothes washers, toilets, and dishwashers. The little black whisker bars here are the 95% confidence bound. So places like showers where they overlap, we can't say with 95% confidence that we've reduced shower use. We think we have reduced shower use, but from just a straight per capita comparison, we can't say that. But on toilets, clothes washers, and dishwashers, yes. And really, clothes washers end up being sort of the heavyweight champion of indoor water efficiency so far. And that's largely because the useful life of a clothes washer is much shorter than the useful life of a toilet. Clothes washers are replaced, there was about 14 years was the old average useful life. I think it's gone down to 12 or maybe even lower than 12 years. So essentially, clothes washers are being replaced, and they are being replaced with the only products that are available, which are by and large more efficient models. Similarly, toilets are more slowly getting replaced over time, and so we have additional potential there. Dishwashers use very little water, about 5 or 6 gallons per load. Yeah, they've reduced, but I mean, you're squeezing the lemon about as far as it's gonna go there with dishwashing. Hot water use. This study, we measured from about 100 homes, 94 homes, cold water and hot water use. And as a basic rule of thumb, about 2/3 of the indoor water is for cold water, and 1/3 is for hot water. The biggest users of hot water, though, are faucets and showers. The others are really pretty small. And the key thing is that means that it's going to be harder to reduce hot water use in the future. The reason for that is because faucets and showers are the discretionary uses of hot water. Human beings turn it on, human beings adjust the temperature, and it's generally about the behavior and the comfort level desired. Those changes are much harder to achieve than simply reducing the flush volume of a toilet or reducing the hot water use through a clothes washer. We've got most of the hot water savings out of clothes washers. They don't use much anymore. So I think there will be some reductions in hot water use, but those savings will be harder to achieve than I think some of the lower hanging fruit in cold water. Okay, so if we compare the two studies in terms of the relative efficiency, so in '99, there was only 6% of households that had a clothes washer that used 30 gallons per load or less. 30 gallons is not very efficient. So we'd gone up to over almost half of the homes that had a clothes washer that used 30 gallons or less. That's great, but that means we still got another half that can get better. And we know 20 gallons per load or 15 gallons per load is really the technical what can be achieved today without any real loss of performance. So there's definitely water savings there. Similarly with toilets, we set the criteria at 2 gallons per flush for the whole household. So they had to have most of the toilets replaced. Only 8.5% of the homes met that criteria in '99. By 2016, we're up to 37%. Yeah, that's great, but shoot, that's what, 63% that's still flushing at higher than 2 gallons per flush? Those are real savings. On the other hand, most people shower at 2.5 gallons per minute or less, and they did so in 1999 in that study, and only a comparatively small percentage had changed. So there you're dealing with a situation where we'd already achieved a technical level of efficiency, so additional savings would be harder to get from that category. All right, so there's another study which looked at multifamily water use. And there's a lot of numbers up here, but I'm going to go all the way over here. If we want to look at the per capita non-seasonal average daily per capita use. Now, non-seasonal is a fancy way of saying indoor. So this is our best analog to some of those numbers that I was presenting you on the indoor single family per capita. And so you see it's quite a bit more variable, but 55 and 54 smell a lot like the 58 gallons per capita that I was presenting. So my point here is that multifamily is going to be in the future. There's going to be more multifamily constructed than single family. So if you're thinking about future water demands in your area, you probably in the residential side are going to be thinking more about multifamily. So it's important to start thinking about that from the various different perspectives: the use per dwelling unit, the use in the per capita, and then that non-seasonal. Now, for comparison, we did another large multifamily study which came out in 2004 that I worked on, which had a larger sample size than this study. In fact, they found a range of 121 to 143 gallons per unit per day, and so that compares pretty well to some of these multifamily numbers also. But again, quite a bit of variability. So it's going to be important to understand the water use in your own service area to be able to make an accurate forecast and to understand the future potential. Okay, I'm getting there. I got 5 minutes. That's good. Okay, so how much more efficiency? I think there's a lot more efficiency. Nationwide, I would say we're only about halfway to what I would describe as the technical achievable efficiency that doesn't require behavior change. The newer technology is making a big difference. I mean, we've seen it with toilets, we've seen it with clothes washers. We're seeing outdoor efficiency really take hold. There's a new study from the Alliance for Water Efficiency on landscape transformation that found water savings from almost every single type of outdoor intervention that was practiced. It also found that over the long term, landscape savings were maintained and in sometimes increasing. So I see great potential there. Kevin is going to talk about what I see as the biggest future savings area on the indoor side, which is leak detection. And that's going to be accomplished through advanced metering. And this is sort of diagram shows the whole concept of collecting meter data at the home, sending it back to the utility, and then feeding it back to the customer also. So there's this two-way usage of information. The key thing is that once the utility starts interrogating water meters every hour, then you can understand if the water never shuts off. And what has been determined is that if the water never shuts off for 48 hours or for 72 hours, that becomes an actionable event, and the utility then can send an alert or a message to the customer, say, hey, something's going on. You might have a leak. And so that's a powerful ability to communicate that we don't have right now. And leakage is a large part of indoor water use, and it's usually a small number of homes that have a very high leakage. There's also a study that will be coming out later this year on meter sizing. And particularly in multifamily properties, there's pretty convincing evidence that water meters are oversized, and that many multifamily properties could be served with smaller water meters. That has a lot of different implications for utility planning, but it also has implications for the sizing of plumbing inside of buildings. Maybe we'll be able to reduce some of that. So this is an area to pay close attention to also. But we're really going to see the use of information and data to help customers understand their water use, to identify abnormal patterns, and to get action to rectify problems much sooner than we have in the past. So I have a great confidence that we're going to continue to see the reductions because of programs like this. So it's hard to make predictions, especially about the future. It's often dangerous to do that. But I think I'm pretty confident to say that climate change is going to impact water systems. It's going to impact them differentially. We're going to have wet years like this, and we're going to have dry years. We're going to have more of a ping-pong, yo-yo effect, if you will. We are going to see more efficiency, and we're going to start to see demand reductions focused at the customer level. Water budgets, water targets, water allocations. I mean, this is something that we've seen California go in for whole hog. And for good reason, because it's really an effective way of identifying high use. We're also seeing the cost of water and wastewater in particular skyrocket, and that is impacting lower income people, and that is something we got to pay close attention to. Affordability issues are going to rise up to some of the forefront of what utilities have to think about and how they're going to collect revenue. Anyway, so that's just some basic ideas about what I see, and I'm going to wrap it up there. And thank you very much for having me, and I will wait and answer your questions at the end of the session.
Thank you, Peter. I introduce our next speaker, is Rob Zimmerman. Rob is currently the Director of Sustainability at Kohler in Kohler, Wisconsin. In his position, he leads efforts to create strategies and tools to capitalize on Kohler's leadership in design, energy and water efficiency, and sustainability while reducing the environmental impacts of Kohler's operations, products, and supply chain. And with that, I will pull up your slide, Rob. Yes. Just gonna grab the right file. Okay, I think you are teed up. Sorry about that.
That's okay.
Okay. Welcome, Rob.
Yeah. It's a lot of drama. So, yes. So, well, first of all, greetings from Wisconsin. It's great to be here in San Francisco. It's one of my favorite cities in the whole world to visit. Unfortunately, I don't get to stick around for much more than a day, but it's wonderful to be here. And again, I appreciate the invitation to speak. I haven't been at all 15 or 16 of these events, but I was at a couple of them in the mid-2000s when it was a much smaller event. And so it's great to see that it's grown this much. So I wanted to talk a little bit today about obviously our perspective as a manufacturer, a product manufacturer, what's coming around water efficiency. And I knew I was going to be following Peter on this. It's like, okay, so I can't go into the charts and graphs. He'll do that for me. And I said, well, what would a group of water conservation professionals want to hear about that I could tell them that they might not already know? And of course, that occurred to me that it's like, well, I'll talk about projects that we've been working on at Kohler, and then draw conclusions from those that we're drawing that are informing our product development and our product strategy going forward. Some of these things are unique to Kohler. Some of them others in the industry are working on. Other industries are working on them. So there's nothing really proprietary in this, but it is a perspective from a manufacturer. And you know, I think as you're thinking about what is the next generation of water efficiency look like, one of my key messages was what Peter just said, which is that we're not done with the old generation yet. There's a lot more work to do. There's a lot more savings to be had out there by replacing what's already installed in people's homes. But that we will continue to work on new technologies, and if you're in the regulatory space and you're thinking about using regulations as a way to reduce water use in your service area, please involve industry. Sometimes we feel like we're pushing back a little bit, but the situations that I've been involved with, things like working with the EPA on the formation of the WaterSense program, took a long time, but working collaboratively created better long-term sustainable results. So if there's technologies, if you're thinking about reducing the next toilet gallons per flush by another 1/10 of a gallon, talk to industry first, please. Okay? So I'm going to talk about 4 projects, and these really start from, I'd say, from the back of the sort of the water and wastewater management side of things, back much more towards what the homeowner or the user will experience. And because all of those things are important, we need technical solutions, but we also need to be cognizant of how people use products and how they want to use products. It's maybe amazing to all of you in here, but most people don't think about water conservation 24/7. They don't want to think about it. They want to do what they want to do, and they want it to work the way they want it to work, and they want it to be right. They want to be doing the right thing, but they don't want to have to put in any extra effort to do so. So the first project I want to talk about has nothing to do with water efficiency as an objective, but it certainly has applications for this. This is a project that Kohler got involved with about 5 years ago with the Bill and Melinda Gates Foundation and their Reinvent the Toilet Challenge. If you're familiar with this project, Bill Gates has certainly been a leader in advocating and spending money from his foundation to promote global health. One of the biggest impediments to global health in developing countries is water and sanitation. And he said that there's a lot of organizations working on clean water. Nobody wants to deal with the other side of it, so he was going to invest in the sanitation. Is there an alternative to the flush toilet? I work for one of the largest flush toilet manufacturers in the world, and I can tell you the technology doesn't make sense in a lot of parts of the world. And those are the parts of the world that are growing the most rapidly and need to conserve water and need to handle human waste safely. So it's a fundamental problem there, but it's also a growing problem here in the US as we have aging infrastructure issues. We have, as Peter alluded to, elevating costs of providing services. And if you can treat wastewater from a single building and do it particularly in rapidly developing places where you don't need to run sewer lines. Now, in the US you might have to do it by regulation, but there might be places where you would want something like this. And you want something that's got a small footprint, you want something that can almost run itself, and there's a reason that this technology has taken 5+ years to develop is because it's really hard to do. Particularly as you scale down. Our original vision for this was having actually a single fixture, a single toilet that could treat its own waste. Really, really difficult to do that because of the variability in what's being treated. So this unit here is in Coimbatore. We've got several of these installed in that city. That's a test city that the Gates Foundation brought us to. And they're treating wastewater, black water from a 6-unit apartment block. And it took us a good year to get this technology figured out, but it is now running and running in a steady state. We are taking wastewater, treating it. It's only held in the system for less than 24 hours, and then back up to a feed tank on the roof of the building and used for toilet flushing again. So we have actually closed the loop. That's what CLASS is, closed loop advanced sanitation system. So it is difficult. It is energy intensive. We've done a lot to drive out, to make it more energy efficient. It's still, I would say, not ready for prime time. But a technology like this is that can be off-grid, run by solar, has a lot of potential in new developments where you don't really necessarily want to run sewer, or you don't have a good geology for a septic system. So I think I talk about this as a reuse solution. There's vendors out here at the exhibit talking about reuse. All these technologies work. You need to find the right one. And if you're in a market where you're looking to do promoting on-site reuse of water, there's a lot of technologies. There is a lot of hands-on work that's involved with some of these systems, particularly if you're treating gray water or black water. It's our experience. Okay. One of the things we really tried to do with CLASS, one of the things that the Gates Foundation liked about it was that we were using electrochemical. We were basically running a current through the water, creating chlorine in situ, and then that was what was disinfecting and treating the waste. The advantage to that is that now you're not temperature dependent. So you can run these systems in cold climates as well as warm. You're not, biological system has to be maintained at temperature. But what we found fairly quickly is that you still need the biology treatment. If you try to run it purely on electrochemistry, you run a lot of juice through it, and it costs a lot of money. But again, getting these systems to steady state takes some time. The equipment requires some maintenance, and they're still expensive to operate. So my perspective on water reuse is that the technology is evolving, but you got to pick your technology very carefully for your application. There is no one size fits all with reuse. Okay. Second project. We're good corporate friends with Whirlpool, and two great Midwestern companies. Whirlpool's doing some amazing things on appliance water efficiency. And one of the projects that they did is they have a good relationship with Purdue University, my alma mater, and they took this old 1920s bungalow house that's just off campus, and they retrofitted everything in there, everything that uses water, everything that uses energy, and they metered every single end use of it. So this is an individual case study of all of the global work that Peter and his team do. We know to the drop how much hot water and how much cold water is used at every faucet and fixture. We know what the temperature of all those flows are, so we know the embedded energy in it. Same thing with all the appliances, all the energy use. The project itself, the home, did I lose my mic? Okay, good, okay. The home itself is run entirely off of solar. It's off grid. Their intent was to have it entirely run off of rainwater and on-site treatment. What they've found is that they still have to take about 20% of the water demand from the utility in Lafayette. So getting to net zero water is really difficult. And you can't do net water because you can't send excess water back through the pipes like you send excess electricity from your solar back into the grid. But they were able to reduce significantly. One of the things that's been interesting about this is they collect a lot of data. And Kohler's involvement with this project really has been, we donated products and we helped with some funding, but we also helped with some technical, particularly the data analytics. And the home has sensors all over it. They collect over 200 million data points a month in this house. And of course, then if you've got that much data, you need to have a way to plow through it. And so one of our engineers worked on some algorithms to do that. We get all sorts of interesting little tidbits of information out of this that I think are informative for us in how people use water. Again, this is like 4 graduate students. It's not a demographically, statistically significant sample. But you find out college students do some strange things in their homes. I don't know if you realize that or not. And it all comes out of the data. I was very disappointed how little they used the bar sink, by the way. But these are shower traces. Okay, so these are 2 different showering events by 2 different people. And this first one on the left is somebody turns the hot water on and they let it go until they think it's hot enough. Maybe they're sticking their hand underneath it, we don't know. And then they get in and take their shower, right? And you can see that little wavering there is the pressure temperature balancing valve doing its thing. The one on the right is somebody who wants to turn the water on and then adjusting it up and down, cold, hot, waiting for it. And what you see here, I don't know if you can read these numbers, this person waited 84 seconds from the time they turned their water on till the time they got in the shower. That other person was 181 seconds, so over twice as long. So all that water is just going down the drain. And what this shows is these kind of things show us is how much variability there is in how people interact with their plumbing fixtures and how that greatly affects how much water is used for the entire trace. So you see that this, count the seconds here, the other showering event is quite a bit longer because of that lead time up front. The actual time they were in the shower is about the same. We've seen evidence of this all over this house, people, how they use their water faucets. They'll turn their hot water faucet on to wash their hands, but there's no way, the hot water doesn't get to the faucet by the time they're done washing their hands. So why did you use hot? But that all that energy now is now in the piping system that gets dissipated into the house. There's all sorts of evidence like this. The idea here is very simply, we have engaged occupants. It's not like they don't know that all this is going on, that they're being watched by these sensors all the time, but yet they still behave this way. The house had a gray water system in it, a packaged gray water system, and one of the things, they had gotten it to net zero energy. Then they put the gray water system in, all of a sudden the energy use of the house went up by 20%. So taking a gray water system in-house, in essence, you've now transferred that energy demand from the utility to the homeowner, okay? And that has to be accounted for. So there is a trade-off there. The other thing is in thinking about what I mean by age of water, if that's, I know in the utility it means one thing. I mean, it's worth thinking about is how long is the water sitting in the pipe? So the water is delivered to the distribution system with a residual chlorine in it, and then it works its way through and even gets to the house, and it could sit in a piping system for weeks in the house. And we actually can know that now. So the idea of maybe we need a duty flush to flush out to keep the lines clean, that's an example of a technology here. And then finally, the plumbing system design has all been optimized to reduce the amount of water sitting in the system. But again, so this is a mix of behavior and technology that really shows how much variability there can be in how people use their water. I'll move quickly through this. This is a project we were involved with last year. Virginia Tech, their School of Architecture, actually had a project in the Solar Decathlon in Dubai. They won the Solar Decathlon in Dubai. They were the only US entry, and they won this. This is pretty cool. And what they've done is they engineered the house from the ground up. It's a modular home, so modular construction, so they have a constructed plumbing chase in there, really optimizes water use, and they got rated on all of this stuff. That's how they were able to win the water efficiency and energy efficiency of this. And what I wanted to come up with here is this idea that a fabricated, constructed home or a better plumbing design is really critical. If you're building, whether it's a multifamily home or a new single-family home, whatever your plumbing system goes into the wall, you're stuck with. So as we think about how do we work with home builders to construct, to do better plumbing design is really important. Okay? And then real quickly, I'll finish up. This is not an advertisement for Kohler. This is just our version. A lot of the other plumbing fixture manufacturers have plays in Internet of Things or smart home. Okay, this is ours, and it looks really pretty. These are glamour shots from the kitchen and bath show, but the idea here is, you can flush this toilet with a voice command, like Really? Who cares, right? It's all Alexa controlled. Stephen Colbert actually did a little bit on our toilet being flushed by Alexa, which I'm not going to show. You're laughing, right? So, or you can give a voice command to that kitchen faucet and say, I want 8 ounces of water, and it'll give you 8 ounces of water. Okay. Why would anyone do that? Okay. Now my smart home marketing people are probably cringing. They can hear me talking, but the point of this is, don't judge this by what we're doing today. This is like, I bought a new car in 2005, and I said, why would I want a USB port in a car? Why would you need that? Now everything you do is voice activated. Everything you do, once the technology platform is in place, the app developers will come up with some really interesting things. And so as smart home gets more widely adopted into new homes and maybe even existing homes, the appliance manufacturers, the plumbing manufacturers, your TV electronics, consumer electronics folks are all into this. And there's no reason the utilities shouldn't be either. So I've seen the AMI displays out there, and that's certainly been a big thing. What can you do if you have a smart home platform and you have a smart water meter and you have smart devices as a utility provider to help your ratepayers use water more efficiently and use energy more efficiently? That's a whole big area of development. I think 10 years from now we'll see, again, you got to make it simple for the homeowners, seamless for them, but that's coming. And then I would just point out my last point, don't forget about data privacy. This is a real concern too, because once you know how people use water, you really do know, like we know about those guys at Purdue, what they're doing in their house, and privacy becomes a big concern. So that's my take. Thank you very much.
Thank you, Rob. Our next speaker is Kevin Galvin. Kevin is a water conservation administrator who develops and manages water conservation programs with the San Francisco Public Utilities Commission. After spending nearly 2 decades working in the field of water conservation for large retail and wholesale water agencies, Kevin knows what drives water conservation program development, participation, and water savings. Kevin has managed programs in the residential, commercial, and landscape sectors, and most recently, SFPUC's Automated Leak Alert Program. In addition to program management, Kevin has extensive benefit cost analysis and water conservation forecasting and modeling experience. So please join me in welcoming Kevin as I attempt to get his presentation teed up here.
Thank you.
Somebody can tell a joke.
I think that first one. So good morning, everyone. I'm really excited today to talk about residential family home leaks and SFPUC's Automated Leak Alert Program. But first, just a little bit of background about the SFPUC. We're a wholesale retail supplier of water to 27 different water agencies. We manage 11 reservoirs and maintain over 280 miles of pipeline. In the city of San Francisco, which is our retail service area where we operate most of our water conservation programs, we have approximately 178,000 customers. And in 2018, J.D. Power ranked the SFPUC number 3 in water conservation satisfaction. So this first slide pertaining to my presentation today is a map of San Francisco. And what we put this together to show what single-family homes, leaks in single-family homes really look like in the city of San Francisco. And what you'll see on the legend is that the size or diameter of the circle indicates the leak size, and the color indicates the amount or the duration or the amount of time that the leak ran. So as I click play on this, you'll see leaks open and close throughout the city. And hopefully this will work. Let's see. All right. slowly, it looks like I cannot get this to play at this moment. Or is it playing? No, it's not. Okay. Because I'm seeing a... Yeah. Okay. Just give me one more second, because I really do like black balance. Oh, no. All right. That didn't work. Okay. So really what this would show, it's we really geocoded 1 year's worth of leaks to a map of San Francisco, and it shows how leaks open and close throughout the city of San Francisco for single family homes. And if it were working, what you would see is in the north side, the west side, and the south side, that these leaks open and close at a constant rate. And when I first started working with our leak alert program, I kind of thought we were working with a fixed number of leaks and that we would move through those and indicate that they have a leak and then work on a smaller amount. But what this map really shows is that leaks are opening on a constant basis. So it's something that's living and breathing through the city almost. As Peter mentioned, with codes driving efficiency for fixtures such as shower heads, clothes washers, toilets, looking for water conservation savings in areas like behavioral consumption or leaks is going to be what agencies start to look at in the future. And if this were working, it really hit home the point that leaks can happen at anywhere, anytime, to any home. So these would be opening and flashing, and I would like you to imagine that happening in San Francisco, but not only San Francisco, but the Bay Area, and then the whole state of California. And it would really underline the importance of leak detection in an urban environment. So we'll move on from that slide. But what are the impacts of leaks to single family homes? Potentially in San Francisco, a sink leaking at 15 gallons per hour had the potential to increase residential water use by 470%. Toilets, we found 17 gallons per hour, 533%. Shower heads at 12 gallons, 377%. And irrigation as the largest at mean leak rate of 38 gallons per hour increased a typical San Francisco bill in water consumption by 11 times. So in order to implement a leak alert program, the SFPUC implemented advanced meter infrastructure. So we did this for several reasons. It allowed us to change out meters that weren't operating or functioning properly. We moved from bi-monthly billing or billing every other month to billing monthly. And it gave us the capability of implementing an automated leak alert program. So really how this system works is it's a fixed network of 84 data collectors spread throughout the city, and about 178,000 meter transmission units, or MTUs. They use the Clara Star system to transfer data to a custom in-house AMI data screening tool. There, the information is screened, validated, before it's sent to our customer portal or our My Account portal. And that's where customers can go online and view their hourly or their monthly, daily, weekly, and hourly water use. So what we've done is gone from bi-monthly billing, or telling people about how much water they used 8 weeks ago, where they can now go online and see hourly water consumption just 12 hours ago. And that's a really quantum leap in providing information to our customers as far as their water use. And it's an important tool in educating customers about how they use their water. And this is just a little graphic showing the interface for our My Account software. So that system is the backbone of our automated leak alert program. We didn't start out automated. We had a pilot program where it was a manual program where once a week we sent postcards to people that had constant consumption or residents. And that was a manual process that looked once a week. It was a little bit limited in scope. So we were looking at ways to increase the effectiveness of our program. And we did that by partnering with a company called ACS. It's a nonprofit organization that was working with SFPUC's emergency alert notifications. And we partnered with them to develop their iInfo system to meet the needs of our program. And by doing that, we rolled out a completely automated system that looks for leaks on a daily basis instead of weekly. We were able to add voice call, text message, email, and letters, and we're no longer doing postcards. So really what that means is if you have a continuous consumption in San Francisco for more than 3 days of a cubic foot per hour or higher, you're going to get a text if we have your mobile phone. You're going to get an email, you're going to get a letter, and you're going to get a robocall. So we're really doing everything we can to notify customers about leaks in their homes. We provide 3 rounds of notifications with all the methods that we have. The notices are available or come out in English, Chinese, Spanish, and Tagalog. And the system's completely configurable and scalable, meaning that as we move forward, we're adding sectors, different customer sector types to this notification system. And we can set the thresholds where we want to, specific to the sector, and tailor the thresholds and the duration, the leak durations. And as we have that capability, we've recently added small multifamily properties. So in September of 2018, we added 2 multifamily properties with 2 to 5 units. And just this month, we actually launched our dedicated irrigation accounts on automated leak alert notifications. So when we're contacting our customers about leaks, we're really urging them to take action. So the first action is to investigate the leak or to call a plumber if they don't feel qualified to do that. But they can also schedule a free SFPUC water-wise evaluation where we'll come out and help them and try to identify where the leak is, and if they have a faulty toilet flapper, we'll provide them a free flapper at no cost. So we do have some services available to help them. They can go on my account and see if any actions that they've taken have stopped their constant consumption. So if they replace a flapper valve, they can go online and see if their continuous consumption has stopped, which is a pretty good tool for them. As far as information, we have a dedicated home leaks webpage, and that provides an FAQ, a leak guide in English, Chinese, and Spanish. And if they take care of their leak quickly, they can qualify for a bill adjustment, for a high bill adjustment through our SFPUC Customer Service Bureau. So, findings. Since we launched the automated program in September of 2017, we've issued about 27,000 notifications to 6,580 homes. So that's approximately 6% of SFPUC's single-family customer base. And we've been collecting a lot of information about leaks and their duration. So luckily, a majority of the leaks are relatively small. 44% of leaks recorded were 1 cubic foot or 7.48 gallons per hour, and another 25% were 1 to 2 cubic feet. So that's 69% of all leaks recorded were 2 cubic feet per hour or less. It's important to note, though, that there's 15% at 5+ cubic feet per hour, and those are larger leaks that are going on out there. And then length of time to close. So this is another, some good information here is that approximately 68% of leaks close within 1 week. So customers are taking care of their leaks if they know about them. And just about, I think about 89% are taking care of them within 4 weeks. There are 298 down there that did take more than 10 weeks to close their leaks. It takes a little while sometimes to get the message. So while we're collecting information about the duration and the leak rates, we really wanted to know more about the program effectiveness. So we specifically about water savings and about the effectiveness of our messaging. So we partnered with M-Cubed to do a research project to find out the effectiveness and answer the question, how much water does the single-family leak alert program save? And we did that by using AMI data information. We compared time frame before we were sending out leak alerts and looking at all the leak information to when we were running our automated program. And the results of that comparison showed a 46% reduction in leak volume, which is very significant. A total single-family program savings of 31.2 million gallons per year, plus or minus 4 gallons with a 95% confidence interval. So that's very statistically significant findings through this study. And as a footnote, this water savings is about 4 to 6 times higher than we previously estimated. So it's a pretty effective program that we're seeing. And the other component of what we wanted to learn was done in a separate research project. We partnered this time with a UC Berkeley researcher, and we wanted to answer the question, how much better do multiple communication methods compare to a single letter being sent out? Since we were rolling out this automated program with all these different ways of notifying customers, and we devised a research project where we divided our leak alert notification recipients into 2 groups. Group A that received all the points of contacts that we have on record, and point B only received the letter. So we ran that for about 4 months. And what we found was that customers that received multiple methods of contact were twice as likely to take the initial steps of taking care of their leaks. So the multiple means of reaching customers seems very effective. And we also looked into how quickly they responded. 40% did not respond any faster as they were quick to fix their leaks, and another 60% responded 6 days faster, 20% 8 days faster, and if 2 points of contacts were received, they were potentially 16 days faster. Overall, multiple communication methods caused customers on average to fix leaks 3 to 6 days faster. So, as part of our research study, we did a survey of all the participants that received leak alert notifications during that time. So we sent out 2,112 surveys and got a response rate of 586 responses. That's a 28% response rate, which is pretty high for just a public agency survey. But I think that was contributed to people really being proud of what they did as part of a follow-up of their leaks and taking care of them. And we asked questions about the leak type and about their awareness. So we were able to get positive information back about what type of leaks they actually had. And it looks like we're still coming back to toilets in the land of water conservation. No matter how far we want to get away from it, it always comes back to toilets. So 50% reported that their leak was a toilet leak. And that was followed up by 8% leaky irrigation, and 7% left their irrigation system on or had a running fixture. 4% burst pipe, 15% unknown. I guess they called a plumber, didn't know exactly what happened, but took care of it. This chart to the right, the bar chart to the right, shows the median leak rate and the range of the leak rate. So leaky irrigation system had the highest median leak rate at 15 gallons per hour. Well, that was actually tied with irrigation or the hose being left on. And it kind of trails down to leaky toilet, which is at 7.8 gallons per hour. While it had the lowest median range, or median leak rate, it had the widest range, ranging from 7.48 gallons per hour all the way up to 225. So that's a pretty significant toilet leak. Yeah. No, well, I couldn't say. So we also did ask about their awareness because we're messaging them and this is a new program. So we said, were you aware of the continuous consumption prior to receiving the notification? And a resounding 75% were not aware that they had a leak on their property. So this is really telling us positive feedback that our program is being effective in communicating leaks to customers. 15% said they were aware and had already taken care of it, and another 10% said yes, but they hadn't resolved the issue. And one of the last questions on the survey that I'm going to cover, how did you go about trying to stop the leak? The largest percentage at 31% called a plumber, 21% tried to fix it themselves, and 22% replaced an old inefficient fixture with a new fixture. So challenges to this program. While it's proving to be an effective program with water savings, it does have some challenges. Customer contact information, we can only send information or notifications out to what we have in our customer care and billing database. So it's really important for water agencies to keep their information up to date. You know, emails are always changing, cell phone numbers are always changing. So getting that information, keeping it up to date is critical. Cost. AMI deployment is not inexpensive. It's a large capital cost, tens of millions of dollars in a city like San Francisco. But we do estimate about an 8 to 10 year payback period on that investment. Volume of data. We collect over 1.5 billion data points a year specific to water use. Multiply that by the 5 or 6, 7 years we've done the program, billions of data points associated with water. And while it's easy to look at as site-specific data, it's harder to look at the data in aggregate with so many data points. Customer education on resolving leaks. Customers call us even though we don't necessarily need to hear from them, and they want to tell us they know about their leak, they're looking for assistance. So educating them on different ways and providing more materials for them to fix the leaks themselves is something that we're working on as well. And then striking a balance of communication. In this day and age, everyone's getting unwanted email, texts, phone calls. So we're really trying to not over notice, but ensure our customers know that this is a serious event, that it's something that they need to take care of. So future direction, this is my last slide. What we're doing now is we're in a research study with a data scientist that's looking at developing an AI or machine learning algorithm to look at all billions of our data points and identify anomaly data use. So this would be really effective in areas where the water consumption isn't going down to zero. So continuous consumption isn't a good way to look for a leak where water's constantly being used. So instead, what we're trying to do is identify abnormal use and then notify our customers of that. And I think that that'll really be the future of how we look to set relevant thresholds for large multifamily properties and developing thresholds for commercial properties. So that's something that we're working on now, and it's a different take on how we'll identify leaks, but I think it's something that'll be necessary for us to reach those customer segments in a meaningful way. And with that, I'll wrap it up and give it back to Julie. Thank you. Thanks.
Thank you, Kevin, Rob, and Peter. So I want to open it up to questions. I'm going to walk around with the microphone. So raise your hand over there.
Kevin,
Yes.
are there programs in place to incentivize landlords or homeowners to replace their toilets?
I'm just checking. Is this on, this microphone? You can hear me? Okay, great. Yes, for the city of San Francisco, we do operate currently a direct install program where if you have older 3.5 gallon per flush toilets and you're either a single family or multifamily property, you could participate in that and actually get replacement toilets or urinals at no cost.
And what's the participation been in that program?
It's been relatively high because it's free, but we've been offering free toilets for a long amount of time. So it is challenging to get people's ear, but we've replaced thousands of toilets through the program.
Thank you. Andy Pease, I'm a city council in the city of San Luis Obispo. We had a water offset program where in order to do some construction, everybody had to go and pay for water toilet retrofits in other homes. So we feel like, check, we've really kind of taken care of that. What do you think are kind of next opportunities that are implementable for a kind of a water offset program? Is it changing out shower heads? Is it kind of the smart meters? How can we be strategic with an ask?
Well, I would still focus on toilets and clothes washers. Those are the things that have been shown to concretely save water. Faucets and shower heads, sure, but again, since it's so behaviorally based, you cannot guarantee the savings in the same way. So if for an offset program, I'd want to make sure that if you're going to require somebody to pay, that they're really going to deliver some savings. And so I would still focus on those two for indoors on those two areas. And then, of course, what Kevin described in the leak detection, if a utility can do that, that is phenomenal. I mean, the reducing indoor leaks by almost 50% is akin to cutting your toilet usage in half or something. It's non-trivial.
I would just echo what Peter just said. When it comes to water savings, relying on a behavioral component, you can't rely on that too much in the long term. And toilets and washers are the real drivers of indoor water conservation.
Robin with Zone 7. I have a question for Rob. Since you guys are really investing in artificial intelligence where you can turn and flush the toilet, and we see that from Kevin's study and that toilets are still one of the highest leaks in the home, is there a way that, are you guys considering developing technology to say, oh, your toilet's leaking or the toilet's running? Since you're asking it to flush, can you ask it to tell it when it's leaking?
Yeah, there's a lot of things that are in development right now. I think that this is probably not a secret, but people have talked about dual flush toilets. Am I picking up here or not?
Your mic.
Yeah, Dual flush toilets. Well, with the right sensor and the right toilet, you don't have to do a dual flush. It'll flush the amount of water it takes to do the job. That's under development. Things like the leak detection is a good idea. I mentioned the Renew House project. Here you had 4 college students who knew that they were part of this house. We had a situation there with a toilet leak. I'll confess. It was refilling over 100 times a day.
Wow.
Just a little bit at a time. Yeah. And you'd think somebody would notice that. They didn't notice that. We picked it up off the data chart. So once you start getting those sensors and that AI in place, there's all sorts of things that can do. Your house can almost have its own self-diagnostic.
Yeah, that would be great. I mean, it would help reduce the leaks for toilets. It would help reduce the leaks for faucets even, because you can talk to a faucet. Now you can censor a faucet by walking up and it turns on and off. But the only thing I don't want to see happen is, like, the sensors and faucets in laboratories that we see in public spaces where it still keeps running.
Right.
Just recap that quickly and let's go to the next question.
I was stating that we have in public spaces toilets that automatically are battery operated, and that they all of a sudden, when the battery starts going bad, the sensing declines. So it's either always running or not running. So we need to have like a second measure in place. They do have toilets now, well, they've had them for years, where they are automated and they have electrical and plumbing. It would be something like that you would probably have to consider.
Yeah, I think what we're seeing with all of this smart home is that there's this co-development of the platform, of the actual fixtures, and then the sensor technology. So there's been a great improvement in sensor technology for faucets and flushometers and things like that. And that's continuing. So, but your point about sort of redundancy is a real good one. That needs to be built in.
Good morning. My name is Susie Marzola, and I'm an architect. I was hoping maybe it's you, Peter, could give us the big picture. How much water use is attributed to indoor residential compared to water use on either a local, regional, state, national? Can you give us just the big picture?
So indoor water use depends on where you are, but in let's say a western city, residential, like a typical single-family home, will use between 50 and 60% of the water indoors, and so that means another 50 or 40 to 50% outdoors. That's typical. I mean, it's going to vary all the way. You're going to have some that use 80% outdoors and some that use 80% indoors. How that like scales up, really, so residential water use tends to be 60 to 70% of the total pie chart for a city, usually. Again, it varies. You have some cities that are more heavily non-residential, but a place like New York City, I think it's 60 to 70% is a large urban area. It's fairly typical. In terms of then, if you want to scale it up to a state level, let's say California, agriculture is by far the dominant water use. I mean, you're probably talking 85 to 90%. So the urban component starts to look a lot smaller as you pull back. And then if you want to go nationally, the largest withdrawal of water is thermoelectric power. Now, a lot of that water is actually used and put back, so it's not consumptive the same way that agricultural use is. But in the big picture, that's sort of where things are. But the thing the reason we focus on urban water use is because that's the water we spend the most money on. That is the water that we spend so much money to acquire, to treat, and then to deliver over thousands of miles in some cases, pumped up and down and up and down. And so that's why it becomes so precious to conserve that water in particular.
Thanks for the talk, guys. Bringing it back to urban water use, we talked a little bit about sensors and how to detect leaks with sensors, but is there a way that just like your average person can detect a toilet leak? Are there tips for people in ways that we can kind of figure that out without sensors in the short term?
Food coloring. You just put a little food coloring into the tank, and if it appears in the bowl, there's a leak. That is the basic test. there's also just listening. And then the other thing someone can do is if you can locate your water meter, you could take a reading and then you make sure everything's shut off, take a reading and then wait an hour or so, take another reading and see whether there's any water passing through the meter.
Yeah, those are good practices to do periodically. Again, people aren't water geeks and doing it all the time, but I'd say people should be looking at that at least once a year. If they think that they have a leak, the dye test is a real simple way to do it for a toilet.
The other part that I would just state is looking at your irrigation system. We did see some of the largest leaks in irrigation. And when you're turning up, irrigation systems typically run when people aren't looking at them in early hours. So really when you're tuning up your system in spring to turn it on, you really need to do an evaluation and look to make sure that there's no breaks in that system. Really the irrigation controller is like a gate valve that just can cause flooding if it's not really monitored properly.
Hi, thank you for sharing all your data about sort of showering behavior. I recently researched a bit about this NASA technology that has been now commercialized into a shower system that is a closed loop water system. Wondering if you guys have vetted it and thought, and can you kind of speak a little bit about, is that the future that we're going? And the second part of the question is whether the gray water system is a solution if we can really change people's behavior.
So 2 questions. Regarding recirculating showers, those have been around for a while. Again, that's one of those things that's really benefiting from some technology improvement. My company does not have a recirculating shower on the market yet. Others do. The challenge I think there that we're concerned about is the health issue. So if you're, normally those things have some sort of disinfection, whether it's UV light or something like that to make sure that water that is now being taken out of your drain and then pumped back through and recirculated and now atomized, which means you can inhale it. There's concerns about things like Legionella and that. I think those can be handled from a technical standpoint, but that's one thing that really needs to be addressed. Having said that, it's a huge potential in terms of energy savings and water savings. You can reduce your energy use for a shower by 80 to 90% if you're recirculating that water and reclaiming the heat from the drain. And then your second question was about
Gray water.
Gray water. Same basic concerns about gray water. Again, using it for irrigation, no issues there. Using it to bring it back into a building. Again, now if it's a packaged gray water system, your water quality in your toilet, again, you're not directly exposed to that, but it's in the house, is dependent on the functionality of that equipment versus like a purple pipe water where you have a professional, treating that water and making sure and accountable for the quality of that water. Again, I think this is something as this technology develops, sensor technology develops, you'll be able to understand if the system is performing correctly or not. And I know a lot of the packaged gray water systems are including that. It's getting better.
So I would just add from an agency perspective, SFPUC does have a gray water program where we offer incentives for laundry to landscape reuse. So sites that meet the program criteria, they have to have their landscape actually downhill from their clothes washer. They can participate in that program. So we do offer that. I think regarding showers, as code impacts the efficiency levels of different indoor water using equipment, showers are starting to become a larger piece of the indoor water use pie as well, since there's a behavioral component of that.
I would also just point out that you need to, when you're thinking about gray water and any kind of recirculation, you need to weigh the benefits of doing it at the individual customer level versus doing it at the community scale and collecting the wastewater at the sewage treatment plant and treating it and using it that way. I think for many communities, they're going to find it's a much more cost-effective ways to do it at the community scale rather than having a whole bunch of small systems which can fail, cause health problems and things like that.
All right, I have a question here, there, and then sir, I'll get over to you.
Hi, thank you guys for speaking. I had a question. I understand that they're considering cutting the WaterSense program. How do you think that'll affect water efficiency in the future, especially regarding industry?
And we're not going to let them do it.
That's right.
Okay.
That's a non-starter. It's not going to happen. I mean, and if the federal program were to be cut, then it would be adopted by states, would become a state program, which would be even more problematic for the manufacturers. So no, it's not going away.
Good answer.
Yeah.
I had a question for Kevin regarding the city's infrastructure. Given the fact that we live in an active seismic zone, I wondered, is the distribution system robust enough, and has it been retrofit so that in the event of any seismic activity, we still will be getting water to the buildings and our homes?
Well, the city of San Francisco does operate within our service area and does main replacements of areas that are at higher risk for rupture. We're actively doing that on an annual basis. There's also a backup system called the AWS system that's used for firefighting that could potentially be used in the event of an emergency. So there's some redundancy in most of the city of San Francisco for water supply.
We also recently are nearing completion of a major multi-billion-dollar capital infrastructure upgrade to our regional water system, in part specifically to help with that seismic safety and future sustainability.
I'm a little disappointed there's been no discussion about trying to change building codes to move to 1.5 gallon shower heads instead of the 2.5. I have one in my home. It's very, very nice. Secondly, also no discussion about cisterns. A gentleman here was talking about the percentage of water that's used outdoors, and why do we need to be shipping water hundreds of miles when it can be collected right here and then used outdoors?
So I can speak to the building code question. There's really no reason not to do that. There's hundreds of models of 1.5 GPM shower heads on the market right now. If a community or a state feels that that's in their best interest to move in that direction, there's product on the market. Okay, so that's just a question of regulatory. And we certainly have done, the industry has done a lot to improve the showering experience at that sub 2.0 gallon per minute range. So I've got a 1.75 in my house in Wisconsin, and it's been there for years. It works great. So I think that that was always in the industry's concern, is are people going to not like it and then turn off to the whole idea of water efficiency in their shower? We think we're past that.
I think the code is 1.8.
Yeah,
right.
1.75.
It is here now. Yeah.
And I'll speak to the issue of cisterns. I view cisterns similarly to localized gray water systems. Some cases they may make sense, but in general, I think you need to weigh it against the value of collecting stormwater on a community scale and whether it makes more sense to do that. There, in many cases, you find cisterns constructed in areas where there just isn't enough precipitation. It can't be taken advantage of year-round. It only works largely in climates where it never freezes. So yes. I mean, I don't want to say that you certainly don't want to look at cisterns, but I think you need to look at water supply, take a step back from the bigger picture. And for many communities, it's going to make sense to have a stormwater program that takes advantage of precipitation as it falls and then collects the stormwater at a community scale.
Thank you. Gopal, there was a community up in the Napa Valley that encouraged its residents to conserve water during the drought a few years ago. The residents responded so well that the city couldn't make their water revenue rates, and so they bumped up their rates and annoyed a lot of people. Is there a solution to that? Have you encountered this before?
Well, yes. So I have a saying that I like to trot out when someone asks this question. It's like, conserve water or don't conserve water. Your rates will go up. The truth of the matter is that there's upward pressure on rates, and there's 3 studies that I would have you look at from the Alliance for Water Efficiency, and they basically look at, well, what would have happened if these communities hadn't conserved water? And the analysis is that the rates would be even higher because of all of the additional water supply and infrastructure and costs associated with delivering the more water. So yes, your rates go up with conservation, but they go up less than they would if you had to provide all of that additional water supply.
I'm going to take 3 more questions.
This is for Kevin. I wondered if you've heard of the root zone system for third world treatment of water. It's a simple system that has a rectangular box with 3 compartments, and the first compartment has plants and uses aerobic digestion, doesn't use any energy. And then I wondered if you'd also heard of the living machine, which also uses plants. The Omega Center is processing all the black water on their campus at a building that has a living machine, and they pride themselves on the fact that they can hold yoga classes in the building and nobody smells anything.
Yeah, that's a great question. We are familiar with the living machine. Actually, the headquarters of the SFPUC at 525 Golden Gate was the first urban use of the living machine. So we actually have a living machine in our building that I work in. I don't do yoga in the building, but I can attest that it does not smell, and we're pretty happy with the way it's been working.
Okay, I'm going to take 2 more questions.
Yes, I have a question about residential use of water for landscaping. I have several friends who never water anything in their yard, and they don't use any water for it, and it looks great. They let natural things grow, whatever grows, grows, and they let it turn brown half of the year and green half of the year. And I have another friend in Scottsdale, Arizona, who regularly gets cited by the city inspectors who drive around and give them a tag for having anything green growing in their front yard, i.e. weeds. You know, it's dryscape, gravel, and cactuses. So during the drought, people weren't supposed to use water to water their landscaping. Wouldn't that be a good permanent policy?
Well, from an agency perspective, I think we're really encouraging customers to use water efficiently rather than necessarily really dictating what type of plant is put in. A lot of people might think that turf has no place in a world of conservation, but there are areas where turf could be used, and as long as it's used efficiently and watered efficiently and it's a water efficient type, then it's serving a purpose. We do have local regulations regarding how landscapes should be installed to meet state and local code, but we do dictate a certain level of water efficient plantings, but we haven't gone to like a xeriscape requirement at this point.
All right, I'm going to get one last question here on the microphone. I think you, yep.
Hi, this is for Rob actually, and kind of a follow-up to the lady's question just 2 questions ago. I'm wondering if in your work and looking at other countries, I found that really interesting, especially developing countries, if there have been technologies or applications of technologies that you could see returning to places in the U.S. where they're appropriate, rural communities or other situations where there's extreme water stress, and if you've had any conversations in the U.S. with about that, because I think there's something we could learn there as well.
Yeah, I think what you see, I just got back from India last week. I was there for 2 weeks, and what you see when you visit places like that is an amazing amount of creativity, because they have to be, and they are able to get through meet their water needs, not the same way we do, but they do it with at a lot, in some cases, a lot lower cost. And so there's definitely technology there. So the system that, you know, I mentioned the Gates Reinvent the Toilet Challenge. You know, we're one player in that. There's a lot of other technologies, some biological, some, you know, thermal technologies that are being used. But the way most people do it is the old-fashioned way, which is composting, letting nature do its thing. The challenge you have is, I mean, that'll work in a rural area. It does not work so well in an urban area. And I think that's, so there's definitely technology there. There's know-how that people have figured out because they've had to figure it out that have applications here on Indian reservations, rural areas in Appalachia, and places where, again, where the geology doesn't allow for septic. There might be different approaches that we can take, above ground treatment, things like that. And then on the water side of it, people are doing all sorts of things in terms of catching moisture from fog, catching, doing a lot of rainwater collection and storage and treatment and all that. So there's definitely, people do it when they have to do it, but there's a lot of wisdom there that we can learn from.
Well, thank you all for attending the Water Efficient Home of the Future panel. As I mentioned before, lunch is provided on the second floor. If you are here to get credits, make sure you sign up if you're looking for the AIA credit, or you self-log for USGBC. Our panelists will be up here for a few more minutes, so if you want to come up and talk to them one-on-one, please feel free to do so. And again, thank you again. Enjoy the rest of the conference.